To our CAD class on how to use Onshape. We're Team 2901 Purple Gears. We're so glad you guys have decided to join in. Today's class is going to be on making sketches and creating parts. So we're going to be learning today how the different components of a sketch, how to dimension sketches, make sure they're all exact, how to turn those sketches into actual parts, and then also how to edit pre-existing parts, like U-channels and bars and stuff like that. I'm going to go and pass it over to Elam, who's going to be doing the main portion of the presentation.
All right. My name is Elam, like Tom said before, and I'm going to be explaining how part studios work in Onshape and how you use them in 3D modeling and CAD. So here I have basically this is what a part studio looks like right here. You have 3 planes, you have a bunch of options over here. You have all your planes listed here, and you have your sketch here. So for those of you who don't know what a sketch is, it's basically kind of like a 2D CAD drawing that can be turned into a 3D part. So this is how you make custom parts. In order to make a part in Onshape, first you have to make a sketch of that part, and then you extrude it, which I will also explain later. So I'm going to just delete this real quick, this sketch, and I'm going to show you guys how to actually start making a sketch. So right here in the top left, you have create new sketch, or you can hit the Shift S key. Onshape has a lot of useful hotkeys. I like to use the hotkeys, but I'll also say whenever I'm clicking a button or if I'm using the hotkey. So you have to hit a sketch plane. So select a sketch plane. So for this demonstration, I'm just going to use the front plane. I'm going to click on it, and then it selected the front plane. So now the sketch is going to be in the front plane because you got to have some surface in order to do your sketch on. And now you can either hide all your planes by clicking the eye and hiding them all, or you can hit the P key. I'm going to hit the P key and they all show up, and I'm going to hit it again and they all disappear. So basic Onshape controls. So if you guys are new to Onshape, or if you have used SolidWorks or Creo, Onshape controls are a bit different. A mouse is strongly recommended. You can use Onshape with a trackpad, but I would not recommend using a trackpad. I would really recommend using a mouse. So the controls are, in order to rotate your view, you can right click here and you can rotate your view like this. You can't see my physical mouse, but I am right clicking in order to kind of move your sketch back and forth like this. You have to basically hold down your middle mouse wheel, hold down middle click basically, and then you can drag it back and forth. And those are just the basic Onshape controls. If you zoom in, you can zoom in and zoom out using your scroll wheel. You can also get exact views by with this view cube. Basically you can click like front, right, back, or bottom, whichever you prefer. And also, since I'm a hotkey type of person, shift 1 through 7 are the basic views. I'll go over those real quick. Shift 1 is front, shift 2 is back, shift 3 is left, shift 4 is right, shift 5 is top, shift 6 is bottom, and shift 7 is a view called the isometric view. And you can also click some of the corners in the cube in order to just switch your view however you want to switch it. So now let's just get to the actual sketch. So now that you know how to use, basically know your way around Onshape, I'm going to show you some shapes, some construction lines. So some construction shapes, sorry. So before I start teaching you guys how to make shapes, here is an example of how you would use construction lines. So what are construction lines? They're basically like reference types of lines that you use in order to reference different types of sketch geometry. So the special thing about them is that they don't show up when you extrude your part or when you turn your 2D sketch into an actual 3D part. You just use them for reference in case if you need them like to position your sketch entity in a certain place and that you actually don't need it there. So the keyboard shortcut for this is right here. It's Q, or you can click on the construction button, and that's kind of a little overview on how to use construction lines. And this works for any sketch geometry for circles, arcs, lines, and rectangles or squares. I will explain how to make these soon. So how you would make one, let's say I'm gonna make a line. So I'm gonna go over here on my top left and just click on the line tool. And now I'm gonna click here, I'm gonna make my line. And then what I'm gonna do is you can do this in different ways. You can click on the line and either go up here, hit the button or hit Q to make your line construction, or you can click on the entity, right click on the entity, sorry, and then you can also hit construction. And it can be reverted, toggled on or toggled off. You can toggle on or off the construction option however you want it. So remember, if it's a dashed line, that means it's construction. It means it won't show up when your sketch is extruded into an actual part, but when it's a solid line, it will be shown up and it will be extruded. Now, the next, what I'm gonna start talking to you guys about is basically the basic sketch geometry. So I'm gonna be talking to you about lines, rectangles, circles, arcs, and points. Let's start with lines. So a line is basically a segment, or the hotkey for making a line is the L key. So you can make a chain of lines also. So you just click at one point and then you move your mouse or drag your mouse across to where you want the desired endpoint to be. And then you click, and then you can also keep making lines until you reach your endpoints. Let's say I want to make a triangle, and then I click here, and then I can also end the line chain there. And there I have a closed polygon. So as you can see, the color switched. So it's turned into a gray color. This is actually what you need in order to make a shape. So before, as you saw, construction lines didn't have this gray shade when they were a closed polygon. That's because they were construction and they're only used for reference. But when a sketch is shaded in gray, that means that's a good thing, meaning that it can be extruded into an actual shape. That means there are no open lines or any open spaces, so that way it can actually be extruded. And then lines, you can start a line anywhere. I mean, this is the L key again, and then you can start it off from the origin, and you just do a normal line. In order to edit a line, you can just literally move it like this. You move one of the endpoints like this. And that's basically how lines work. Obviously, you can get more complex with lines. I won't go over that now, but when you use sketches, lines will be very crucial. One line alone won't give you a part, but if you connect multiple lines together to make a polygon, it will connect the part. Next, what I'm going to go over is rectangles. There are two types of rectangles I'm going to show you, a corner rectangle and a center point rectangle. I'm going to start with the corner rectangle. The hotkey for this is G, so I'm going to click on it. So you just start one place, for example, my origin. I'm going to click on it, and then I'm going to move my mouse out until I want my desired size from one corner of the rectangle to the other corner of the rectangle. That's why it's called a corner rectangle. And then you click, and there you have your rectangle. And then it can be, you can move it around like this. You can move one of the corners around like this to edit the size of your rectangle. The next rectangle I'm going to show you is a center point rectangle. And then here, it's different because the rectangle, as it's called a center point rectangle, it has a center. So then you click on it and then you move it out like this. You extend it out to your desired length and width, so however wide and long you want it. And then when you're done or satisfied, you just click it and then you have a rectangle. Unlike lines, rectangles since they're already closed polygons, they automatically become a gray shape that can be extruded into a part. One thing to notice also that rectangles can be made into squares since there is no option for making a square. Next, I'm going to be talking about circles. Now, there are different types. You can do a 3-point circle and an ellipse, but for FTC teams and for robotics in general, we mainly use a circle instead of an ellipse, and more specifically a center point circle, which is because it's kind of easier to make. So the hotkey for this is C. So just click on a place like the origin, for example, and just move your mouse out. And then you can make it as small or as big as you want it to be. You click on it, and then like the rectangle, it's already a closed shape, so it can be extruded into a part right away. Also, if you're noticing how I'm deleting this, so how you delete sketch entities real quick, you can either click on the shape and you can right click and hit delete sketch entity, or you can click on the shape and hit the delete key, or you can just drag select the whatever sketch entity or sketch entities that you want to delete, and you just hit the delete key or right click and delete sketch entity. And then it's gone. Next, I'm going to go over arcs. Two types of arcs, arcs and tangent arcs. I will not be going over these types of arcs. So the 3-point arc has the hotkey of A. So I'm going to click there, and I'm going to click on a random point, the origin, and then I'm going to move my arc across. Let's say I want it over here. This is going to be my end point. I clicked on my starting point, and now I'm going to click where I want my end point to be. And then I'm going to also move my arc up and down just based on where how big I want it to be. So the last point, if you can see that little point beside the 8.545 under that, that's basically the center of the circle that this arc is making. So for those of you who don't know, an arc is literally a part of a circle. So the arc size of the arc is based off the radius of the circle that it makes. You click and then you're good to go. So those are the 3-point arcs, 1, 2, and 3. Next, I'm going to be talking to you about the tangent arc. So what is a tangent arc? It's kind of different. So for this one, you're going to need a line. So as you can see in this little diagram right here, there's a line. So I'm going to start off with making a line. So click my line tool again, and I'm going to make a line right here. And then I'm also going to be making another line like this. So now I'm going to take my arc, my tangent arc actually, and start it off on the end point of one of the segments, and then move over and until I reach my desired size or the other end point of the segments, and there you go, you have a tangent arc. That's how a tangent arc works. I'm going to also be going over points right after this, but just a heads up, tangent arcs, although they attach to the points of lines, they won't attach to points by themselves. So a point is literally just a point. It's mainly used for reference. It's like construction lines and lines on their own. They won't extrude when you make the part, but they are useful for holes, which I will not be going over, but holes are basically just removing material in the part that you have. So let's say you have, let's say, a circle. I'm going to make myself a circle, and in that circle, you need a certain point and a certain location at that circle. Well, you just put a point here, and you have a reference to where you would put, let's say, a line right here. So you can start a line from here and go to here, and there you have exactly where you wanted that line to be in that in this scenario. So points are very useful for many different scenarios. Also, another thing I'm going to be going over just really quickly, not too much in depth, is the text feature. So for FTC competitions, you're required to have a side plate with your team number on it. So this is very useful and handy for making your side plate. So you click on the text, there's no keyboard shortcut for this. It's basically a corner rectangle like I showed you guys before. You click and you move out until you have about your desired size, and then you click, and it's going to give you this dialog box right here. And then here you can type in whatever you want. I'm going to type in 2901. If I were going to make a side plate, you can change the font, whatever font you want. You can make it bold and italic, and you can flip it around. And then you hit check, and then you have your sketch, and then you can just dynamically also move it around like this. Now that I've talked to you guys about basic sketch geometry, there's obviously more, but I won't go in depth with that too much. I'm going to start going over some of the tools that Onshape has to offer. So first one I'm going to talk to you guys about is the trimming tool. So here I have this sketch. I have a square, 2 lines bisecting the square and the circle, and I also have that's pretty much it. That's the whole sketch. But I'm going to introduce to you guys the trim tool. So this scissors right here, this is the trim tool. The hotkey for this is M. And that's basically how the trim tool works. So let's say I don't want this arc anymore right here. Well, that's fine. I just click on it and it automatically deletes. If I didn't have the trim tool activated, it would delete the entire circle, which is not what I want. Let's say I want to delete this part of the square. That's fine. I can delete that. And there you go. It's deleted. So you can hover over and see which segments can be deleted. So you can see that they all have endpoints, and then depending on those endpoints, that's the area where it's going to be basically deleted. That's the handy thing about trimming, is that it's not going to delete the entire sketch entity. It's just going to delete that part of the sketch entity that you would like to delete. Next, I'm going to be talking to you guys about the offset tool. So what the offset tool does is basically it makes a sketch entity a copy of it, a replica of it, but it makes it a bigger or smaller version of it. If you're still kind of confused about what I'm talking about, that's okay. I'm going to demonstrate it to you. So here I have just a random sketch here. And let's say I want to make this semicircle bigger. Just a copy of this, a bigger copy of this. So I click my offset tool, which is right next to the scissors, the trim, and next to this tool right here. And then I click it, or the O key if you're a hotkey person. And now that it's activated, all I do is I click on a sketch entity like this. And as you can see, it literally makes a copy of it, but it's kind of like a scaled copy of the sketch entity. You can do this not only for one, but for multiple sketch entities. You can do this for lines, arcs, circles, pretty much most things. But if I were going to offset this inside here, it wouldn't work. But let's just say that I did this, right? So it says can only offset a single chain at once. So what I did is that you see how I'm offsetting all of these in a row except this one. So it's like a chain, and I just broke the chain. So it gave me an error saying can only offset a single chain at once. So in order for me to fix that error, I just click here and then I keep going. So if you ever receive that error, it could be because you accidentally forgot to click one of your sketch entities, which I do have a decent amount here. Now to change the size, I just click, and then here you have what's called a dimension. I will be going more in depth into that later on, but you can change the size of it to 3 inches or whatever, whichever size you prefer. You can also go smaller than the actual sketch right here too. That's basic offset for you right there. Next tool, very useful, very great time saver, is called mirroring. So here's what a mirror looks like. Let me delete this real quick. So we're going to be making that. So I'll demonstrate that to you. So here I have just a random sketch with a bunch of circles, rectangles, and semicircles and segments. So what I want to do is I want to do this again, redo this sketch again on the other side, but I don't want to have to do every single circle and every single rectangle and every single semicircle again. That would take way too much time than it needs to be. So Onshape has a handy tool called mirroring. There's no keyboard shortcut for this. It is beside the 4 squares and the offset tool. So the mirror tool, you click on it, and a construction line is recommended for this. Like I said before, for those of you who don't remember, this is used for referencing, so you can reference it, and it's not going to show up in if you extrude the part. So I select this line because this is where this is going to be mirrored over. So it's going to translate itself or reflect itself across this axis on the other side. And then I can either select one entity like this, and it only copies that one, or if I'm going to redo this again, I'm going to do my mirror again to demonstrate to you guys. So I want to do this whole thing. You can drag select the entire thing, and it will be mirrored to the other side. Now, as you can see, this is actually a good example of when a construction line is useful, because as you can see, it's just a random line there, and you don't need it for if your part is ever going to be extruded there. It's just there for reference. That's how mirroring works. Imagine having to do that entire thing, redo it 2 times over. You don't have to do that. You just mirror it over. Next, I'm going to be talking to you guys about linear patterns. Linear patterns are also another time saver, very useful, speeds up production of anything. Let's say you're making like a set of holes or a set of different parts. Linear patterns are the way to go. So this is what a pattern looks like. I'm going to demonstrate to you guys how to use it. So I'm going to delete these. You can make a pattern from anywhere from 2,000 to 2 to 10,000 times. So like you can replicate this square, for example, 2 to 10,000 times. So here you have this square or rectangle. Yeah, it's a square, I think. But you want to make 24 other copies of it. Now you could basically do like this. You could just make another one and just go off of that. But that would take way too much time and way too much energy. So what you do is basically you take, oh, sorry, by the way, this is a rectangle. You take this pattern right here, linear pattern, very useful. So it's beside your mirror and it's beside this DFX icon right here. So all you have to do is you click on it and then you click on the selected sketch entity or sketch entities that you have. So you can actually click on, let's say, one line and it'll be patterned like this. You can just pattern that singular line of the rectangle. Now, what I'm going to do, though, I want to actually pattern the entire rectangle. So I'm going to highlight my entire rectangle and pattern it like this. I can, as you can see right here, that 4.57, that's dynamically changing. You can change it to whatever size you want. This number is the distance between the left side of the rectangle and the left side of the replica of the rectangle. And not only can you do the pattern horizontally, but you can do it vertically also, and this will make a pattern of that same pattern that you just made. So it's a pattern of a pattern. And then here again is the distance from the bottom edge of this rectangle to the bottom edge of your replica rectangle. So now I'm going to click OK, because as you can see, it has on my cursor as like a mouse with a check. So I'm going to click left click OK. And here I can still edit what I have. So I can change this to, let's say, 5 and this to 5 inches. And I can also change the amount. So that 2x and 3x are basically the amount of that sketch entity that you pattern. So I want 5 of these rectangles across. Give it a moment to load. There we go. So now you have 5 of these rectangles across, and now you want 5 of these patterns of these 5 rectangles. You can also change that. And you just made a grid right there. Patterns are very useful instead of having to do the same repetitive thing again and again, repeating with the same sketch entity. That's basically how you do linear patterns. Now, the other types of patterns I'm going to show you, another one actually, is circular patterns. You see this shape right here. So for those of you who use Actobotix or Tetrix, you may have to model a custom part or parts that either needs to be 3D printed or milled or cut out of polycarb or whatever, and then you're going to have to make a certain hole pattern to accommodate the Tetrix or Actobotix hole pattern you use. So this is why circular patterns are useful. So again, I'm going to be using a construction geometry. So I'm going to be using a circle. I'm going to click on my circle or hit the C key. I'll just go on my origin and then I'll move it out to my desired size. I'll say I want it that big. And then now what I'm going to do is I'm basically going to first make it a construction, obviously. So I'm going to click on my circle and then click on my construction. Now it's a construction circle, won't be used in the actual making of the part. And then now I'm going to make another circle. And I'm going to put it right here. Now I want this circle to be on the bottom to reflect. I want eight circles basically, or 8 holes in this case for the whole pattern. So I want one on the top, on the bottom, left and right, and I want ones in between those circles, right? So what am I going to do? I can either make circles, make all 8 circles, or I can just make a circular pattern that will rotate them around this circle. So I'm going to click on my circular pattern and I'm going to click on the sketch entity or sketch entities that I want to make into my circular pattern. And as you can see, it traced it along the origin, and now it's being traced along this construction circle that I made. And here you have three replicas of this, or two other replicas of this circle, but I want 8, right? So I'm just gonna hit check, wait for it to load, and now I can change the size. The amount that I have. Also, let's just say I'm gonna try to do this again. So I'm going to do the circular pattern of this circle, but as you can see, there's a square right there, right? So let's just say it went off to this side like this. You can also move this around, so you can change where your center of rotation is. So if you add another circle over here, you can change it there, and it's going to rotate around that circle. But since I luckily had my circle in the origin, it's automatically by default going to rotate around the origin. And that's basically how circular patterns work. Next, I'm going to be going into depth about dimensions and constraints. So what are dimensions? They're basically help define a sketch. So you can determine the length, the diameter, the size, like the width, the length or the height of the actual sketch entity that you want to dimension. They actually make your part accurate and make them fully constrained. So the reason most of you have, well, I mean, all of you, sorry, have been seeing that most of the sketches I've been making are blue, and that's because they're not constrained. So in order for a sketch to be fully constrained, the entire sketch must be completely in black. Now, as you can see, almost all of this complete entire sketch, which is just a bunch of shapes, is in blue. And the reason for this is because I can move this around like this, and I can also change the size if I wanted to, like this. Well, no, I can't change the size of these, it's dimension, but like I can move them around. If I actually deleted this sketch entity right here, I can change the size of this. So that's when dimensions and constraints come in handy. I'm going to start talking about dimensions, and then I'm going to be moving into constraints. So how you use dimensions. The dimension tool is up here next to this drop-down menu and this DXF icon. So the hotkey for this is the D key. So you click on that, and then these are most of the different ways that you can use a dimension for. So let's say I want to make this circle 25 inches. I just click on it, on the side of it, and a dimension is going to appear. I can click on it. Once I click on it, it's going to give me this dialog box, and I can change how big I want it. So I want it 25, and then it's going to automatically turn to 25. So lines right here, they're also use the same rule. So it will by default, if you click on a line, it will automatically dimension the length of that line for you. Same for rectangles, because rectangles is literally 4 lines. So it's just gonna, by default, dimension the line that you just clicked on. Another type of dimension is the distance. So here I have the distance between the edge of this circle to the edge of this other circle. You can also do center distance. If I hit my dimension tool again, center this circle to the center of that circle, and then that's the center distance between each of the circles. I can also do distance between 2 parallel lines like this, from one to the other, and that gives me that dimension. And then this is a polygon. I know I didn't go over this, but there is a way that you can make a polygon in Onshape. Sorry, I didn't go over that one. But the way you change the size of this is there's a construction circle, and then you just change the size of that depending on how big it is. And if you click on 2 unparallel lines that are not parallel to each other, it's going to give you an angle option. So these lines are obviously not parallel to each other. So if you hit your dimension tool and you clicked on one line and you clicked on the other, whoops, my bad. I'm meant to click on both lines actually. So let me do it again. Right here, you'd get yourself an angle. This is actually a good monitor to see if your lines are actually parallel in the sketch. And then you can edit your angle as desired. So those are basically the main ways that you can dimension and Onshape. Another one's like you can do from your center to here. That's basically a radius right there. Now I'm going to show you guys what light gray dimensions look like. So let's say I'm going to dimension from this point right here to this line right here of this rectangle. And these dimensions are just going to stay the same. They are there. So I'm going to click on my dimension tool, click on the point, and click on the line. So I just drag out, and let's say I hit enter. And as you can see, it's a light gray dimension, sorry. So the reason it's light gray is because Onshape is trying to tell you, duh, this thing is already constrained. Like 10 times 2 is equal to 20. You already dimensioned it, so there's no further need to dimension it in that sort of way. So once you click enter for this dimension, it can't be edited anymore. As you can see, I'm trying to click it, but it can't be edited anymore. So I'm going to delete this sketch entity right here real quick, and I'm going to demonstrate you a type of common error you can get in Onshape when doing dimensions. So I'm going to hit my dimension tool and do the exact same dimension from this point to this line. So I hit that. Let's just say I want this to be 15. Onshape is going to give you errors. And then obviously there are more complex errors than this, but this is the general idea. You made a dimension that made also the sketch physically impossible to be regenerated. Like it's not possible. Like in this case, I basically said 15 times 2 is 30. So the length of this rectangle must be 30, but no, it's 20. So 30 is not equal to 20. So you either delete this sketch entity right here, and then your rectangle will turn to 30 inches, or you can just delete the previous sketch entity right here to go back to normal if you accidentally over-define something, because that's basically defining the sketch. Now, an example of a fully constrained sketch would be this circle right here. This circle is basically fully constrained. The reason for this is that I started off making the circle at this origin, at the center of this origin. The center of the circle is at the origin. So now when I made it, I also dimensioned it to be 5 inches in diameter. Now, fully constrained, it means it cannot move anywhere. I can't physically move this anywhere, and I can't make this any bigger or smaller. For example, this rectangle, I can click on the center and I can move it wherever I desire. And then if I click, let's say on this right here, let's get out. If I deleted that, I can make this as big or as small as I wanted to. So that's basically not happening for the other circle because it's already constrained to the origin, and it already has a definite size. So as you can see right here, this constraint here is called a coincident constraint, which I will go into depth more in a few minutes. So right here, those are basically main dimensions, and also there are many other ways to do the dimensions. You can dimension, for example, like this line to this point. You can dimension points between each other. For example, you can dimension this point to this point, and you have an exact measurement right here. But once again, like if you made it too big, let's just say you made it 40. Never mind. I apologize, guys. It would be if this line was fixed. Let's just make this right here, and this line is fixed right here, right there, and I decided to change this. Actually, it would give me an error. So let me dimension that again. It would give me an error because basically this has to be a specific length in order for this angle to be possible, and the distance from this point to this point to be possible. So you will run into errors when dimensioning things, so just keep an eye out for those. And one last thing I almost forgot to mention is the arc. So you can see this is the point here. This would be the theoretical center of the circle. So this dimension, the dimension for the arc, is basically based off the radius of what circle the arc would actually make. And those are basic dimensions. Now I'm going to be talking about constraints. So let me go into my sketch. So what are constraints? They relate the position or size of two sketch entities, and they also define a sketch in Onshape. So I'm going to be talking to you guys about maybe about 5 to 10 different constraints in Onshape. The first constraint I'm going to be talking to you guys about is the coincident constraint. So let's just say I have two lines right here. I'm gonna make 2 lines, click my line tool. Whoops. I'm gonna make another line right here. And then these 2 points are obviously not connected. If for some reason I wanted to connect these, like maybe to make a closed shape, I could hit my coincident constraint. So here's a drop-down menu of all the constraints. Some of them have hotkeys, some of them don't. This one, luckily, has a hotkey, which is I. So you click on that. You click on the point of one line, and you click on the point of the other, and they automatically become constrained. I'm going, for the purpose of this demonstration, I'm going to hit the show constraint so you guys can see where they are. So this is a horizontal constraint. I will talk about that later on. But the coincident here, it's basically meaning that these 2 points, no matter how they are, they will not be separated. And if by any chance they are somehow made separated, then it will give you an error because they have to be separated at all times. So this is what a constraint looks like. So if you see a constraint like this, you can hover over it and see the 2 sketch entities that are affected by that constraint. And if you don't like the constraint, you can simply click on it and delete it. Like you simply click on and you delete a sketch entity, and those 2 lines are no longer connected. The constraint also works, the coincident constraint also works for a line and the point on a line. So as you can see, they're not necessarily touching, but they're basically on the same plane with each other. So if I were to move this one down here, let me move it down a little more so you guys can see better. There, that's where it's touching. So coincident constraint doesn't mean that they're automatically not moving. They can still move. They're, as long as they're along the same axis as this line, they are considered a coincident constraint. The next constraint I'm going to be talking to you guys about is the concentric constraint. So for those of you who don't know, concentric means that 2 circles basically share the same center. So I'm going to make 2 center point circles, a tiny one and a big one. Now I want the center of this circle to be in the center of this circle. I will show you 2 different ways to do this, or 3 different ways actually. So you can also do a coincident from these 2 points, because you can coincident 2 points together and they will automatically be concentric. Or you can use the concentric constraint right here, no hotkey, and then you just click on the 2 points and they will be made concentric. Or when you're in the first place, when you're making a circle, you can also just automatically do this constraint by just hovering over the center of the circle and clicking on it, and then moving your circle to your desired size, and it's automatically constrained there by coincident constraint, but it's still technically concentric because the centers are still technically share the same center. Next constraint I'm going to be talking to you guys about is called the parallel constraint. So if you don't know what parallel means, it means like the lines are basically in the, like this. They will never intersect in a plane. So let's just say you have 2 lines like this and you want them to be parallel, or that they never intersect each other. Well, what you do is you go down your constraints. Parallel luckily has a hotkey, which is B. You click on that, and then it's activated. And then you click on the 2 lines or sketch entities that you want to be made parallel, and then they will automatically be made parallel. And you can see the constraint, the parallel constraint. Hover over it and you see that they're both parallel. One thing to note, parallels will not work with circles and arcs. And one other thing to note, coincidence will not work between circles and lines. That's where the tangent constraint comes in. So the tangent constraint, or if you hit the T key right here, is basically used to make a line tangent to a circle. So if you don't know what tangent means, it means that a line touches at one point in a circle. So I'm just going to make my line over here. I'm going to make a circle. I'm using the hotkeys right now to make those circles and lines, and I just make a random circle here. And for some reason, I want the top of this circle, the edge of this circle, to hit on one point in this line. So what I do is I go here and I click my tangent or the T key, and I click on the line that I want to be tangent to and the circle that I want the line to be tangent to, and they will be made tangent. And this not only works for lines and circles, but it will also work for circles. So if I make another circle with the C key, and then I click on my tangent, and I click both of those circles, they are tangent, and they're inseparable, and they cannot be separated. So this is basically the quote unquote coincident for circles and lines together, or circles and circles. Next up, I'm going to be going over the horizontal and vertical constraints. So horizontal constraint, or the H key, basically makes a sketch entity like a line or the side of a rectangle or square horizontal, in this case to the X plane. So basically parallel to the X plane if you want to reference. So I'm going to make a line. So when you make your line, as you can see, you have this like kind of yellow dotted line like this. That makes it automatically horizontal. So you can see that horizontal constraint right there. See, there's a horizontal constraint right there. But if for some reason you have a line, and I hit the L key, that's like this, and you want it to be horizontal, well, you simply go here, you hit the H key or horizontal, and you click on the line you want to be horizontal, and it'll be made horizontal. Same thing goes for the vertical. So for the vertical constraint, so you have a line here, you can obviously make it already right away vertical like this. And then if you have, you can do it the other way, and you have a line like this. And then you just take your vertical constraint or the V key and you click on that line and it will be made vertical. Now let's say you don't have your show constraints activated, and then you overlook the fact that this one is horizontal, and then you choose your vertical constraint to make that vertical. It is going to error because you're basically telling Onshape that this line is horizontal and vertical at the same time, which is not physically possible. So there's an error. And whenever there's an error about anything on a sketch, the sketch will show up red. So if you click on the sketch, it won't be solved completely. If you're going to extrude this into a part, it won't be solved. It's just going to stay red, and it's going to give you the error right there. Sketch 1 did not regenerate properly. Sketch could not be solved because it's not physically possible what I did. So you have to delete either the horizontal or the vertical constraint. It can be one or the other, but it can't be both at the same time. Next one I'm going to be going over with you guys is the perpendicular constraint. So you have two lines here. One's right here and another one right here. And then this line has the horizontal constraint, so it can't be turned around, made vertical, or put off at an angle. And you have this line that has no constraint at all whatsoever. So this perpendicular constraint doesn't have a hotkey, makes two lines perpendicular to each other. So you just click on one line and then you click on the other. And they will automatically be made perpendicular to each other no matter what happens. So if this one was not horizontal and could be rotated, this one will also rotate with it in order for it to always maintain a 90-degree angle. So let me delete that. The next one I'm going to go over with you guys also is the equal constraint. I'm going to be using this, I'm going to be demonstrating with circles. So if you're going to make a Tetrix or Acrobatics hole pattern, most of the time the holes are always the same size except the center holes, obviously. So you don't want to have to constantly dimension all of those holes at once, right? So what you do, if I just have 4 random holes right here, let me dimension one of them. Actually, I'm not going to dimension it. Never mind. I want to show you guys how it works. So right here, there's a constraint called equal, E, and it basically makes two sketch entities to be the equal size and dimension. So if I click on this and I click on this circle and this circle, they will become the same size. If I click on this circle and this circle, they will also become the same size. And if I click on this circle and this circle, they will all become the same size. And it's pretty cool because then if you ever change the size of any of these circles, the size of those other circles are also going to change, as you can see. So that's the cool thing about it. You don't have to dimension every single one of them. I used to be able to do that until I found out this constraint. It was so much easier to do it. It's a great time saver. So that's basically how the equal constraint works. This can also work. I'll demonstrate to you guys real quickly with 2 lines. it won't work directly with rectangles. If you want rectangles to be equal, then you have to get all the lines to be equal. So here you have the equal constraints. So you're going to click on this one, and although you may not see much of a difference, they are equal. And then right here is how you make your life easier when making a square. So you have your rectangle right here, center point rectangle, and then you can do your equals. You can make this side equal to this side, and you automatically have a square. No matter how you dimension it, it is always going to be a square. This also works for corner rectangles, by the way. Now, the last constraint I'm going to talk to you guys about is the midpoint constraint. So once again, a lot of these constraints have to do with lines, but they can also be sides of rectangles too. Anything straight edge type, I guess you could say. And then I have another line right here. So if you hover over this line long enough, you can find the midpoint of it. Okay, so let's just make another line real quick. Sorry about that. So right here, you hover along this line. You see that square? That is the midpoint of that line. So you can click on that, and you automatically are constrained by that, by a midpoint constraint. If for some reason your line is here and your other line is down here, you want to attach it to the midpoint of that line. Let me delete this real quick. Then all you have to do is go down here. There is no hotkey for this. It is just the midpoint constraint down here after the equal. You click on the point you want to be at the midpoint at, and then you click on the line that you want it to be midpoint at, and then there you go. It is constrained to the middle of it. Although you can also move it. This isn't fully constrained, obviously, because you can also change the angle. It's not just constrained there on its own. You can also move it around like this. And that is the end for constraints. Now, I'm going to be doing a walkthrough sketch with you guys. So if you guys have an Onshape account, feel free to pull it up, and so you guys can practice your skills on sketching and see how well you're doing with sketches. So what I just went over with you guys was just the basics. There is still a lot more that I didn't have the time to go over with you guys, but we'll probably try to do a session in the future or something like that. But we're going to be making this sketch right here. It's nothing too impossibly hard, but it uses dimensions and rectangles and constraints. So I'm going to delete this sketch. So if you guys have an Onshape account, feel free to pull it up. And if you want to do this sketch with me, feel free to follow along so you guys can learn. So I'm going to click on my sketch plane. I'm going to click on the top plane. And then next, what I'm going to do is I'm going to hit Shift S or the sketch here on the top left. And then I have a new sketch. Now I can hide my top plane, and I can start sketching. The first thing we are going to do is make a center point rectangle, or the R key, and make it on the origin, fix it to the origin. So that way our sketch isn't moving around in outer space. And then make it a certain size. So there are two ways you can just generally make a sketch. You can make a sketch completely without any dimensions and then dimension it at the end, or you can make a sketch and dimension it as you go while making your sketch. So I'm going to be doing kind of both methods, because I'm going to be doing some sketch entities and then sketching. And then after that, I'm going to be putting my dimensions in. So now that you have this right here, we're going to make two corner rectangles, or the G key right here, corner rectangle. We're going to make them on the right corner, bottom right corner, and bottom left corner of each side of the center point rectangle. And then they're going to basically be coincidentally constrained to the center point rectangle, sorry. So now you can also hover over here. You hover on the bottom left corner of that first rectangle you made, and then you just move out and stay on that line. And then that way, basically, you just made these four sides equal to each other. Now, next, we're going to use the equals constraint again. So click equals. And what you want to do is you want to click on these three lines, this line, and whichever one of these sides you want. Just choose one it doesn't matter which side it is, just make sure it's one of those sides. So let's just say I click those and I click this one and this one. So now all of these sides are the same size. So the height of this rectangle is the same as basically the width of these two rectangles. So now that we have this, we're gonna basically start dimensioning. So what I'm gonna start dimensioning first is this side right here. So pull out your dimension tool or the D key and click on the side and then make this 0.09 inches. You're gonna notice your sketch is either going to shrink by a lot or grow by a little. It just depends how it was. For me, it shrank by a lot because I started off my sketch a little too big. But now that it's 0.09 inches, this is also 0.09 inches. And this is also 0.09 inches. Next, what we're going to do is we're going to dimension the top of this rectangle to be 1.5 inches. And also dimension the distance from this line to this line to be 1.5 inches. So basically what we just made right here is the side view of a basic Actobotix U channel. So now you have your sketch. Your sketch should be completely black. If it is not, then you may have forgotten to either constrain something or you may have forgotten a dimension. But here are all the constraints. It seems kind of scary, but all the constraints you really need to know is the equals right here, and just make sure it's constrained to the origin. And then once again, your sketch should be completely black. Now, something that I need to stress that I've had problems with before is, because of forgetting, is naming your sketches and extrudes and mates for assemblies also. So here I'm just going to name this U channel sketch. This is useful so that way you know you can keep track of what sketch you're using or which extrude did which thing, which sketch was which thing, so that way you don't get lost. So try to start getting in the habit of naming your sketches and extrudes so that way you don't get lost in your own part studio. So now you hit check and you have just completed your first sketch if you followed along. So if you want to figure out if you were right, you can simply highlight this entire sketch. And you see there's a little measure tape here. It says show measure details. You click on that and it tells you the measure details. So if your area is 0.388800 inches squared, then you are right. If it wasn't, I would recommend you look over your sketch because you may have accidentally dimensioned something wrong. So now that I have shown you guys I've walked you guys through how to make a sketch and I have talked to you guys about how sketches work, we need to go into the transition of making a 2D sketch into a 3D part, and that's an extrude. That's called an extrude. So I'm going to make an extrude. So an extrude is basically making a 2D sketch into a 3D part. It is right next to the sketch tool. The hotkey for this is Shift E, and that's a basic overview of what happens when you extrude something or what an extrude is. So you can click on your extrude and then you click on the faces or sketch regions to extrude. So I'm going to click on my U channel. As you can see, my 2D part sketch just turned into a 3D part. It's starting to look a little bit like a standard Actobotix channel. Obviously not much right now, but it is starting to look a bit like it. So I'm going to change my depth to be 1.5 because that's the depth of the actual Actobotix U channel. So what I did right here is basically I did a new command. So that's the only option you have when you extrude solid, like when you extrude a sketch, because you're making a new part, you don't have anything else to add to. All right. There are also other options called add and remove, which I will currently show you right now. So I'm going to click my back view. You don't have to do this along with me, but if you want to, you can feel free to do so. I'm going to make a new sketch and I'm going to make a circle. Just a random circle, just in the middle of this U channel, right? So now I have my circle. I'm breaking the rules because it's blue, but this is just for demonstration purposes. I'm gonna just name this circle sketch. Misspelled that. And then I'm going to hit the check button to confirm that I did the sketch right. Now I'm going to hit my extrude button again, or Shift E. And what I'm going to do is I'm going to click on my circle sketch. Also, a handy thing that Onshape does is as soon as a sketch is extruded, it will hide the actual sketch, so it's not annoyingly in your way. Just something, just a note that I wanted to point out for you guys. So I'm going to click on my circle sketch, and as you can see, it is extruded out. So instead of the new option, you have the add option, which means that you're basically making, you're adding to the part that you already made. You are adding to a pre-existing part. So this is connected, fused together with this part, and there's all still one part. The new option, if you click the new option again, you can see the color of this turn gray, meaning it's signifying that it's another part, it's a different part. So if you notice down here on the, around my bottom left, around here, you can see there's part 1 and part 2, right? Part 1 was the U bracket, now part 2 was this cylinder that I just extruded. So that's, if I wanted 2 parts, this would just turn into a multi-part studio basically. But if I wanted to just do 1 part, I would go back to add. I know I didn't go too much in depth about how extrudes work, so I'll go a little bit more into depth into those now. If it'll load. All right, loaded. So this arrow here you can use to dynamically change how much you want to extrude. You can extrude in both directions. You can extrude in the other direction if you change the arrow. The default extrude is set to 1 inch. So every time you hit the extrude button, it's automatically going to extrude to 1 inch. So you can extrude upside down and you can extrude right side up. You can do, there are different options here. So you can do up to face, which is basically you just click a face here and it will extrude up to that specified face. I have to turn it around. There you go. Like this. If I wanted to do symmetric, it would basically do it like this. So it would basically extrude in 2 directions at the same distance. If I go back to my blind and I have it like this, I can also do a second end position. It's similar to the symmetric, but instead you have it a different distance away instead of actually being the same distance away. So that's basically how you would extrude, you would add material. Now the last option right here is the remove option. So what I'm going to do is I'm going to click on my remove. And what this does is it removes material. It's pretty self-explanatory. So right here, I just made a hole in here. I'm just going to click out of that. So as you can see, selected tools and targets don't intersect. The reasoning for this is that this is basically saying, okay, remove material in this direction, and but there's nothing in that space to move. You're just basically removing empty space, which is not physically possible. So what you do, you can change the arrows, and now it is removing the hole. You can make this hole blind. So let's say there was an actual material here. It would have removed the hole up to that depth, or you can do through all, which is very useful if you don't want to actually do a certain type of measurement. If you just want it to go through the entire part. If in a U channel, for those of you that know that there are holes on each side of this U channel, so all you'd have to do really is make one actibotix hole pattern and then extrude it as a through all to go through the other side. So that's basically how extrudes work. A little more on extrudes. I also have another part here. Extrudes don't always have to be complete sketches. They can be parts of sketches. So if I do extrude or Shift E, I can hit one part of it. So if I can click on the end of this and it will extrude it. I can also click on this one and it will extrude, and click on this last one. So as you can see, I just made 3 parts, a multi-part studio. The reason for this is that they do not intersect each other. They do not merge together. There's no way they can merge each other. If I hit add, it would give me a bunch of errors because there is no way at all that they can intersect each other because they are far away from each other. They're not touching at all. So a new is the most reasonable thing. Also, the advantage of being able to extrude only a couple of sketches at a time, if I'll do that extrude again. So let's just say for this part, I just wanted to extrude these 3 parts right here. And then I'm going to hit check, and I want this side to be bigger. So I want it to be taller than this side. So let's just say it's extruded at 2 inches. So then all I have to do is hit Shift D or my extrude button and click here. Click on these 2 parts of the sketch. And now it's 1 inch, but I can move it all the way up to 2 inches. And there you go. You can have it at different levels. You can have this extruding on the other side if you wanted to, you know what I mean? So you can hide this sketch. You can, if you extrude it again, you can literally extrude this right here. And if I'll switch it, you can extrude like that. So you can extrude different parts of the sketch right here. So that's another way that you can use extrudes. Also, another thing to note that it's the exact same sketch again, but I'm going to extrude the entire sketch like I was doing before. So I'm going to hit my extrude, and then I'm going to click on the sketch. The cool thing that Onshape does is that if you make 2 concentric circles, or not really just concentric, just a circle inside of a circle, then it'll automatically make a hole. So this will save you a lot of time instead of having to make another sketch that has these same 3 circles and then extruding those out as a removed material. They'll automatically, it's not going to necessarily remove material, it's just that that material will not be added. So it's just something useful that Onshape does for you. Next feature that I'm going to show you guys that you can do with parts is called the revolve feature. So here I have that U-bracket sketch we had before, but this time we're going to turn it into a revolve. What is a revolve? So here you have your sketch, and it's basically going to turn around a certain axis. In this case, you can make it this line, or this line, or this line, whichever you prefer, or even that line at the bottom. And then let's just say it's this line, and then it's going to turn around and turn it into a 3D shape. So it's can make it cylindrical or conic types of shapes. So if you don't understand what I'm talking about, that's fine. I'll demonstrate to you. So the revolve tool is literally right after the extrude tool. So you just click there, and this says faces and sketch regions to revolve. Click on your sketch that you want to revolve. And now what you do is you click on your revolve axis. It's giving you an error because there's no axis to revolve. So just simply click on where it says revolve axis and select your revolve axis. So in this case, I want it to be this line.
So we're running a bit long, so we're gonna finish up, and then so we're gonna speed things up a bit.
All right, Tom, do you want me to hand it over to you, or?
No, you can go ahead and finish revolves. We're just gonna.
All right, yeah, that's fine. That's fine. Yeah, all right. So then you have a revolve right here, and it basically makes it spin around kind of like in a circular motion. And you can also, it doesn't have to be full. You can do one direction, and you can click it in a certain degree, like you can do like 100 degrees or whatever. And also you can dynamically change it with the arrow like this, and you can make it however long or however much around that you want. And that's basically the end for me. So yeah, that's basically kind of basics on how to make sketches in Onshape and how to extrude parts in Onshape. Thank you for listening.
So we do have a little bit more on how to edit pre-existing parts. It's gonna go pretty quick. I'll just go ahead and show you guys how to do that. So a lot of times you don't necessarily need to make a custom part. You might just need to, change an existing one. Let me turn on my video. But so, for example, if you're putting a hole in an Acrobotics bar, so what I've done is I've just clicked this derive button over here. It's right next to the X and this little circle thing. So that allows us to bring in the part studio from an existing part. Now, I've seen people use pre-existing parts and then actually just copy their part studios. But what that does is it just creates another copy of that part studio. It doesn't actually reference the existing one. So with derive, what I can do is I can basically reference the existing part studio. So if the existing one changes, this one changes too. And it doesn't end up with messy like copy of copy of copy style things, which is always pain to deal with. So now that we've done this derive, again, it's just this button up here with the arrow. And we navigated to the document where our other part is. We've clicked on the part studio there, and now it's in here. So to edit it, we're just going to make a quick sketch. Select that face, hit sketch. I'm just going to do a square cutout. So I'm going to hit R for the center rectangle. Let's see. And we're just going to be pretty arbitrary. So it's just going to be a 0.75 by 0.75 rectangle, assuming we're using an Actibotix extrusion. Okay. So let's cut out sketch, enter. And I'm just going to extrude that. Remove, because we're cutting a hole. And then through all. And so that's pretty much just how to edit an existing part. It's really simple, but using derive makes your life so much easier when editing existing parts. That's pretty much it. Forgot to mention, we got this part from our FTC parts library. We curated it along with a bunch of other people. It has Actibotix parts from Servo City, Rev, GoBuilda, Pitsco, AndyMark, and a little bit of Big Master. But if you want access to that, it's like all has accurate materials and colors and is reliable with its mates and motion. If you want access to it, you can just go ahead and email first@ptc.com and they will give you access. Any questions? That's pretty much the end for us.
Yeah, I think they have some in the chat, right? Should we check at those now? Look at those now?
Yeah.
All right, let's see.
All right, so it looks like most of the questions in chat were answered during the presentation because
All right,
plans
good.
changed a little bit in motion.
Gotcha.
But does anyone have any questions just in general about Onshape, about Part Studios, sketches? No? Okay. There's actually a poll. Actually, there's only 2 of you guys. So would you guys be interested in an assembly class on how to make Onshape assemblies? Just answer in the chat. Or
Yeah. All right. We have one yes, that's good.
Okay, great.
Yeses, that's great, yeah. That's what I like to do.
So we'll definitely look into that. We'll post information on the same places we've posted information for this. So Reddit, the Discords. Yeah.
All right, that's good.
There is most likely one next week, yes. Unless plans change, and we'll put something on those platforms unless if plans do change. Right? Thank you guys so much for coming.
Yeah, thank you very much for listening. I appreciate it.